Thank you so much, and good morning, PyTexas. How good was Mario's keynote this morning? Important and timely words about fostering and inclusion. Thank you so much. Hello, my name is Simon. I've come from New Zealand to speak to you today about DevOps and security, which is my passion. I'm involved in Python New Zealand, currently the secretary, and I'm on the organizing team for Kiwi PyCon. We host that in Wellington, which is the capital of New Zealand each year. So it's a wee way to go, but if you're ever in the neighborhood, definitely come and check us out, please. By day, I work as a SRE/cloud engineer in the payments industry. And for fun, I do paragliding and speed flying. That is not a picture of me, but I am working up to it. So I spend a lot of my time both at work and in a personal capacity thinking about risk and risk management. As you can tell, I like risk. So let's talk about web application security and risk. In 2017, it was estimated that about 80% of all web applications on the internet had a critical vulnerability. A lot has happened since 2017. According to the Stack Overflow survey from 2024, about 50% of the people, of developers in the industry have entered the industry and have less than 10 years experience. Also more recently, vibe coding has entered the chat. And the proliferation of AI has made building and deploying applications more accessible to people who would otherwise maybe never have considered building their own app. Sometimes for the better, but often for the worse. So where are we today? You would think we'd learned a lot about application security, and we have. On average, our posture has gone up. But a more recent estimate from around 2023 is that 70% of all applications still have severe security gaps. And the amount of code out there is staggeringly more vast. From the GitHub Octaverse reports from 2017 to 2022, there's about 20-fold more repositories in GitHub now than there were in 2017. From 2021 to 2022, the number of vulnerabilities tracked by the US government National Vulnerability Database increased by 25%. I don't have more recent stats, but I can only imagine it's on a similar path of new vulnerabilities year over year. And at the same time, there's an estimated 85 million shortfall of cybersecurity professionals by 2030. It's very common for for companies to have ratios of about 1 security engineer to 100 developers in their company, which means that security engineers are either incredibly stretched or are less doing security themselves and more acting as subject matter experts and trying to influence other application developer teams to help them achieve security by themselves. So with all of this code out there, the question is, who is going to keep us safe and secure? Hint, it's us, application developers. We're going to be responsible for our own security to a large extent. And the security domain is huge. This is many domains of cybersecurity, but there's like one little quadrant that we're going to zoom in on and focus on today, because we have a lot of influence over that, and that is sort of application security, and we're going to touch on a bunch of these. So when we think about risk and security, we can think about a Swiss cheese model. The idea is that we apply multiple layers of protections so that the holes of the cheese have to line up for things to properly go wrong. To borrow a military saying, 2 is 1 and 1 is none. And so today we're going to work through building up our own little Swiss cheese model of security, starting with some of the most common things that developers trip over and cause large incidents with. So the first one, GitGuardian, their 2023 report estimated that there were about 10 million secrets in GitHub, up 67% over the previous year. So that's where we're going to start with our Swiss cheese model. We're going to do secrets detection. And for that, I'd like to talk about one tool called GitLeaks. So GitLeaks is a free and open source tool. And what I want you to take away from this talk is just how easy it is to throw some of these tools into a pipeline and get up and running really quickly. I'm happy to share my slides afterwards, and you can copy and paste the code, and you'll have all of this within like 20 minutes of fiddling. So let's set up GitLeaks. First, we're going to define the first stage of our Swiss cheese model, secret detection. So this is all gitlab.org CI/CD syntax, but you can very easily convert this to whatever system you use. I'm sure it translates perfectly fine to GitHub Actions. So we define our stage secret detection. We're going to create a job git leaks, and that will run in our stage. We need to run it in an image. We can just use the official project image for git leaks, and we just need to override the entry point to make sure that we can run our shell commands in there. And then that's it, one line of script. Git leaks runs in two different modes. You can run it in directory mode or git mode. Directory mode will scan the head of the directory as if you were just scanning a normal folder on your computer. The one we actually kind of want to use is git mode, and that will actually go through and scan your entire commit history. So if you've pushed something, if you've pushed a secret and you've deleted it and pushed another commit, it will still probably be in your history unless you've squashed it. And so this mode will go through and find secrets that are in your history that you think you might have deleted. Cool, so I'm going to throw in some variables here that definitely shouldn't be in our config, but it's a very common thing to do. We want to use our CI/CD to deploy our application to AWS, and so we're going to put our secret keys in there. Definitely don't do this, but we're going to test the tool. And so if I go and run that pipeline configuration, we're going to see that it should fail. And if we have a look at the output, this is what we should expect to see. So it's picked up a generic API key in there. It's telling us the file it's founded on, the line it's founded in. We're running it with the redacted flag, which means that it's not actually going to print out the secret into our logs, which is probably a good thing. But if you're running this locally on your developer workstation, you can run it unredacted to get an unredacted view of what the secret is and whether it's a false positive or something you actually need to jump on immediately. And so that is the first little barrier that we're going to put up to stop us from pushing secrets into Git. And you can see now that our pipeline fails, and that would prevent someone from merging or deploying their application until these problems are fixed. Now, in terms of fixing these problems, it's very hard to go back and remove a secret from Git history or remove commits. So pretty much your only options are to rotate the secret. If you haven't merged it, you can squash the code. And it's important to also delete the branch afterwards, because especially platforms like GitHub and GitLab, they will keep those branches around for quite a long time, even after you delete them. So you've got to clean everything up and make sure to rotate the secret so that it's no longer usable. There's many other tools out there that do this as well. I should mention Trufflehog and Trivy. I don't have a huge amount of experience on those, but GitLeaks is free and open source, and I've used that for production, so it's a good place to start. Last year, this XKCD comic was thrust into the spotlight again because of incidents like XC. Supply chain security is becoming probably one of the most increasingly talked about concerns in software development. We almost had a disaster with XC. PyPI has certainly had plenty of problems that fairly successfully fended off, with people trying to upload malicious packages or take over old packages to push bad stuff into PyPI. And so this is a really common way to get your keys stolen. They're normally targeting crypto keys or crypto wallets, API keys, whatever they can get their hands on, both in your application pipeline and on your developer machine. And so you want to know if one of your dependencies is vulnerable or has been backdoored. And so for that, we're going to talk about the next layer of our model, which is dependency scanning. So all of your Git projects probably have some dependencies, and those dependencies have dependencies. And maybe something down that chain has a bug, or maybe it even has something a bit more malicious. You've already seen solutions to this problem, sort of, through GitHub Dependabot. And if you're using GitLab, there's an open source project called Renovate, which is sort of standalone and implements a similar workflow, whereby they'll go and scan your repositories and do the scanning for you and open pull requests that bump your dependencies to secure patched versions. But we're going to talk about another tool today, something that we can put in our pipelines, and that is pip audit. Pip audit is a free and open source tool that uses the PyPI vulnerability database. And it is similarly just like 5 lines of code to throw into your pipeline. It's that easy. So again, we're going to define a stage called dependency scanning. And we're going to add pip audit. It can just run in the Python image. And it's just 2 lines of script to get that running. So we'll test it out. We're going to put a horrendously out-of-date version of Django into our requirements.txt and see what happens when we try to run this. And as expected, this stage of the job has failed. So let's go and have a look at what the logs say. So pip audit has successfully found 3 security vulnerabilities with that version of Django. It's suggesting versions that we can move to patch that particular vulnerability. Some of those might have their own vulnerabilities as well. So it's basically just a process of go to a new version, rinse and repeat, make sure it's got no vulnerabilities in that. And so now we've added dependency scanning to our model, and our pipeline is failing. We can, if we choose, prevent people from merging or deploying as long as that stage in the pipeline is failing. Cool. Can anyone see a problem with this code? Shout it out if you see the problem. Yeah. All right, maybe something a little bit more subtle. Can anyone see a problem with this code? Yep. Unsafe YAML. We'll come back to these. So OWASP, the OWASP Top 10 is our open source initiative to categorize and provide information about the top 10 most vulnerabilities that are out there running around in web applications. This is how, they publish a new version like every 4 to 5 years, and this is how it changed between 2017 and 2021. As you can see, there's like 3 new ones, but for the most part, it's the same vulnerabilities shuffled around in order. Some of them have been like split, some of them have been combined, but it's really just mostly the same errors over and over again. If we go all the way back to the first version in 2004, like most of these are still the same errors that we're struggling with. Injection, cross-site scripting, broken access control. They're all the same bugs over and over again. So the next thing we're going to have a look at in our Swiss cheese model is static analysis security testing. So what is that? It's like a linter for semantic security problems. It's becoming very popular to the extent that if you start a new project in GitLab, they will give you the option to enable it by default for your project. You use a tool called Secret, which in turn uses a bunch of other plugins. It's cross-language compatible, so you don't just have to use it for Python. And it's a good tool, but the one we're going to talk about today is one called Bandit. It's, again, free and open source, and it's specifically built for Python. It has a few hundred plugins, everything from doing looking for possible SQL injection, cross-site scripting, unsafe use of like evaluation, just loads of plugins, and it gets updated all the time. So let's have a look at how we can put this into our pipeline. Again, it's just like 5 lines of code. We can just run it in a normal Python container, and we'll create a new stage called SAST. The other thing we might want to add to this, though, is the -x option to ignore the .venv directory, because we definitely don't want to scan that for errors. We should probably just focus on our own code, although it is interesting if you find stuff in there. So we'll put that into our pipeline, and we'll run it against some of the example code I saw earlier and see how it performs. And this is the output we should expect to see. So we can see it's flagged that MySQL as possible SQL injection. Obviously, it's a bit context dependent. You probably should do it the proper way, which is to use prepared statements. But the actual impact of this depends on where your application is running. Still, it's nice that it's flagged it, and we can go and fix that. The other thing that's flagged is our use of YAML.load, and it's suggesting that we should use safe-load instead. And I'm going to demonstrate why. So in the case of the SQL, this is all it could take to ruin our day. That would be very bad. In the case of the YAML error, Maybe you're like loading a YAML file, like some sort of platform as a service thing where users can define their own server config. They might define like how the application runs in a YAML format. If we're using YAML.load, then all it would take for someone to come along and ruin our day is something like this to go and execute arbitrary code on that machine. I did not know that was possible. There's other bug classes with YAML that you should look out for. It's possible to denial of service a machine. But YAML parsing is super powerful. And from what I was reading, deserializing and serializing YAML has pretty much the same power as pickling objects in Python. So you definitely want to use safe load by default wherever possible. And don't trust user data there. Cool. So now that that's in our pipeline, we can see it failing, and we can prevent merging or deploying if we find security bugs with that plugin. Now, I want to take a quick diversion. So far, we've been running these in serial because we've been building it up with our Swiss cheese model. You'll probably upset your application developers. You'll definitely upset me because I don't want to sit here waiting for all of these jobs to run one after another. So we're going to do a quick refactor. And we can put all of them into a single stage to run in parallel. And so they'll all run at the same time. You can do this at the same time as your unit testing or like any other like build or setup jobs that you need to do. And these should run in less than a minute or so. And you can run these all the time on every pipeline. Every single time someone pushes, you get all of these checks. Cool. The next one I'm just going to touch on quickly, but not go into any real depth on, is DAST. So unlike SAST, which is statically analyzing your code, a dynamic analysis is actually running probing tests against applications running either in a staging environment, in test, in production. There's two tools I'll throw out there that you can have a look into, Dastardly by or Nessus Scanner. If you've got to this point in your DevOps journey, you're already probably somewhat mature. And you can just run these against either like feature branch environments or like your test environment on the internet. That's fine. We run these around the clock. Pretty cool. So we've added all of this stuff to our pipelines. We're like totally secure, right? There's nothing that could go wrong. Nobody can hack us. Well, not quite. This is our head of security at my previous job. I love her dearly. But as a periodic reminder, you can't use testing to prove security. You can only use it to prove insecurity. So we're trying to find the low-hanging fruit, the really obvious stuff that people might pick up with scanners if they're coming in and harassing our application while it's on the internet. But the last slice of the model that I want to talk about here is you. It's up to us to be aware of what we're programming, to educate ourselves as much as possible by coming to conferences like these, coming to talks like mine. There's like loads of great security conferences. They're not all just about hacking and pwning stuff. There's red team and blue team and purple team talks. And it's extremely invaluable to learn, especially in this day and age. Like I said, we've just focused on a very, very small corner of the cybersecurity domain. But it's huge, and there are thousands of professionals out there looking at all levels of the stack, below our application, the physical infrastructure, the cloud platforms that we deploy to. So we're not alone in this, but we can definitely move the needle on that top right-hand corner. So that's it, a whirlwind tour of pipelines for securing your software development lifecycle.